Hello again, this is Avkash, and if you are a data scientist, a machine learning engineer, or an AI engineer, you build those models, and if you are looking for a solution to manage your models, this tutorial is for you. In this tutorial, we are going to use Comet Machine Learning Monitoring Platform to export our models from machine learning runtime environment or machine learning pipeline and monitor these models, store them, monitor them, version them, download them as needed. Means anything related with model management is going to be covered in this tutorial using Comet Machine Learning Model Registry. So Comet Machine Learning Monitoring Platform has two key features. One is a machine learning monitoring, and second one is the machine learning model registry. I already have a tutorial related with machine learning monitoring with Comet ML, and this tutorial is fully focused on Comet machine learning model registry. So let's get started. To get us started, I already have access to Comet machine learning observability platform, and in this video tutorial we are going to learn how to use the Comet Model Registry functionality. So Comet has a system for logging, registering, versioning, and deploying machine learning models. And these models will be stored at the Comet Machine Learning Monitoring Platform. And in this tutorial, we are going to save that model or export that model from our experiment runtime environment to the Comet monitoring platform. Here is the Jupyter notebook which I will be using, and this Jupyter notebook is going to run at the Google Colab environment, and the same Jupyter notebook will also be available at this public repo, which is public code GitHub repo, and the folder is machine learning and the Comet ML folder, and this will be your Jupyter notebook. This GitHub URL will also be available in this video information section. So this Jupyter notebook I have already used in previous tutorial where I showed how you can use Comet monitoring platform for monitor your machine learning experiment. And that tutorial is already available at YouTube, and the link for this tutorial will also be available in the information section of this video. So if you are interested to learn in depth about this whole experiment as well as how these metrics were stored at Comet monitoring platform, you must visit that video. And this is the place where the model experiment details were saved, and these are the experiment we have seen, and as you could see here that these details are saved from one of my previous experiment for the exact same Jupyter notebook, this one. So it has all that information related with machine learning experiment. It has a histogram. It also has these assets and artifacts which related with my previous experiment. So there is a wealth of information in this tutorial. Now we are going to focus in this tutorial where we are going to export the model from machine learning runtime environment to Comet and explore more about it. So here are the APIs related with model export for Comet in Python. So please visit as you really need it. For more information about Comet machine learning model management platform, please look into documentation as well. So very first, I will just try to make sure that my runtime has Comet available. Comet is not available in this runtime. I will be installing it. Installation is complete. After Comet ML library is installed, we are importing this experiment function, and now we are defining this experiment using the Comet ML Experiment method. And very first thing, we have API key, which we have received from Comet server. And once you have your individual or business account with Comet server, they will give you your access key, which is available here. So I got keys from there. And then it is my project name, so Keras Heart Disease Experiment, because that related with this project, because I will be using the existing project to store the experiment model. That's the reason I'm using existing project. And the third thing is the workspace, and Comet has this a concept of workspace. So depending on your need, you can create multiple of these workspaces. So I'm using avkash-program-com workspace for this experiment. Rest of these parameters are needed to tell experiment method to store or export or sync all of these metrics related with this machine learning experiment to Comet monitoring server. So this experiment is configured, and as you could see here, that experiment detected that I'm running this test from a Jupyter environment, and finally it's suggesting us that when at the last we should use this experiment.end. So all that information related with this experiment, such as notebook, some of the metadata related with the experiment, all that information will be synced to our workspace within the project at Comet Monitoring Server. Next, we will check if we have our test data. So as you could see here, we do have this test data, heart.csv. If it was not there, then we could have used this method to upload the CSV data from local file system to Google Colab runtime. If heart.csv is already there, we are not using that cell. Now we are importing pandas, seaborn, matplotlib, and here is our data frames. So we have seen this data frame, and only certain cell I will be explaining. Rest I will be just skipping at the explanation, because I have already explained a lot in my previous video tutorial related with monitoring your experiment with Comet ML. So if you are interested in execution of every cell, I would request you to please visit this video. These are just pure EDA. Now we are taking our input data frame and extracting the training part and the target part here. Next, we are taking the training content and transforming it. So it's ready for machine learning. And now you could see this is more of a machine learning ready data, which is transformed. At very first step, we are taking the training data and split it into training and test data based on 30% split here. And then the next step, we are taking the training data and splitting it into training and validation data based on 20% split here. So now we have test, train, and validation data. At this point, we are creating our deep learning network using Keras library. And when we say network, our network type will be, or model type will be sequential, and all the layers it's going to have, they will be dense layers. And here, now sequential and dense modules are available for us to use, and here we are defining our deep learning network, and this network will be used to train our machine learning model based on our input data or input and validation data. After this model is defined, we can plot our model to see how our model network look like. I will not be showing this cell for you because this is related with real-time or runtime metrics, as well as the loss and accuracy function visualization. So I'm not using that. So this callback will not be used in this method. So now we are using the 100 epochs to run this experiment for 100 times in order to get our machine learning model trained, and result of this training will be stored in history object. So as soon as we are going to start this experiment, what you are going to see here is that if you are a new user to Comet machine learning monitoring platform, you are going to see a new experiment here. So if you look into this experiment, and as you see here, there is no chart data because experiment is initialized, but we haven't started the real training. We only just work with data preparation as of now. So I will go and I will start the training here, and as soon as the training is started and epochs values you could see here, we can come back and we can see, this is trying to ping the data or collect the data, and refresh. And as you could see here, the new data related with our experiment is coming. Here you could see that this is a batch accuracy, all that thing, validation loss, validation accuracy. So this experiment is already completed. So our experiment, all the 100 epochs are completed. I will skip this, and now we can look into our model summary. Here is our model summary. Here are some of this code to show the model plot related with loss accuracy, with validation and validation loss and validation accuracy. So all that information, if you look here, all that metrics are stored here. We can look into hyperparameters related with our network, and metrics are here. These are the metrics. Here you could see the accuracy is 90.5. So if depending on precision, if you want to match it, you can say 90532. If you look into here, what is your accuracy? It's the model accuracy 91124. Okay, so now you have seen this is your network graph, and as you could see here, very quickly you could see that we have 13 input, and then is a dense layer with 30, and then 20, and then finally 1. So input. After that, here let's look into the confusion matrix if we are interested, but here the model accuracy 9053254. 9053254. So you could see that accuracy is matched. And here comes the important part related with this video tutorial. Now we are going to save this model, and we are going to push this model from local runtime to the Comet. So as we look into here, and what you need to see here is that these are the histogram related with our experiment, and at the very bottom there is an asset and artifact. And as you could see here, as of now, related with our training, all the histograms are available here, and there is no other information we have. So if we are trying to save our model, very first step, they will be available in this assets and artifact section, which is not available because we haven't pushed our model. So first what we will do, we will save our model in this model directory, and our model name will be Keras heart disease bin. Okay, model is saved. We can look into local file system. So here you could see the model folder is created. In model folder, we have this bin file. If you want to load this model, we can use keras.models.load model. So we are reading that model back in the model X object. Or we need to launch this. Now model X is available. Here we can look into the model X metrics. It will say loss and accuracy. Those two metrics we have, and here is our model accuracy, which is available here. Next, we are just making sure so you can get an idea that this is our model. And one thing very good with Comet is that you can actually see the experiment directly in your Jupyter notebook. And here you could see that just making this call experiment.display, we can see exact same experiment related information directly in our Jupyter notebook. And as you could see here, we could see histogram information is available, our histogram graphs are even there. So all that data is being pulled directly from Comet Monitoring Platform to the Jupyter notebook. We can see our charts, hyperparameters, etc. This is a very useful method you have if you don't want to access monitoring platform directly from Comet. And now here comes the experiment.log model. So experiment.log model is defined here. So you can log this model and you can just name your model, and then you can provide the location where your model is. And if there is, your model is a combination of various files, and you can combine all of them within a one model name or one model framework. So now we will push this code to our server. As you could see here, that model related information, because the system knows that it's a Keras model, these content are pushed from server to here, and we can look into, and as you could see here, our model is listed, and this is a Keras heart disease model, and here is our model. And model content is available now at the Comet server. One very important aspect for you to remember is that when you are working with Comet, Comet has runtime experiment monitoring through project and independent model registry. And as you could see here, our model registry is all empty. There is no model registered. And when you are pushing the model details through your project, they are not registered yet, because this is our experiment, and here are our model as project asset or artifacts. But in order to register this model in the Comet model registry, you have to register it. So here I will be registering this model as a version 1, and I would say this model is trained with 13 network 30, and I could set this model is either private or public. So I will keep it private for now, and I will save it. So now this model is registered, and here you could see information about your model, and here is the model detail. So now if you would want to see this model, you can click here, and that brings you to the model registry. So if we come back here, look into model registry, and you could see that we have one model registered here, and this model is Keras heart disease model, and it has only one version. It was trained about a few seconds ago, and here is our model. And this is the model when was created, updated, some of the information. If you would want to download this model, you can download it, and it will download the zip file, which is exactly the content what is just pushed here. So this is the very first model detail you are seeing. If you want to go back from model to the experiment, you click here, and it will bring back to you the same place related with this experiment here. And that's how you sync the model details from your runtime environment to Comet server by logging model, and then after that you are registering it. So that's was very simple way I wanted to show you that now you have model pushed into. At this point, if you retry the training and you push the code, it will move your model back to a Comet server again. So for example, if you are trying to do some training again, and what we do is that we can just run this training again. So we have run this training again, and if you look into the Comet server in this experiment charts, you could see that experiment has started. So it's a new training process started as of now, and at this point you will come back here. So training is completed, and here was our 91124 experiment, and if we try to, you see there is a model accuracy is changed at this point between train and train when we used it. And if we look into the accuracy, here is 99 it's used. And if you would want to save these So we can save this model. So this model is saved local, and now we can push this model from here. So if let's look into this. So this is the artifacts. We can look into here and it will show you that model is okay, and 4 minutes ago it was pushed. Now if we come back here and we try to push the exact same model at the server again, let's come back here. Just I wanted to change the tab, so it's reload again. Model, and you see a few seconds ago. So some of the information is being overwritten. So model, this API does have various parameters for you. So to check it. So if you see here, here are the parameters. Here you could say copy. If you want to overwrite, is false. Okay, so you could choose whatever is best suitable for your project and experiment requirement. So you see that we have this model content available, and because of this model is there, you can download this individual file. Let's click here and open this in a new tab. So here is our model, and we can look into, if you look into here, this model, this is the description which we have added. Here is the experiment related with that model, and if you would want to say something, you could say some staging and various other things can be added related with your model. So what I wanted to show you that when you are changing your model network, if you are making sure that you need to update some of the model versions, or you need to do a new model version, you have to make sure that you are changing some of the settings, and those settings will be needed and they will create a new model version. So you have this model version which is related with this experiment, and that you have to understand. So now what we will do is that we are going to come back to in our experiment, and we will make some new changes here. So if we want to make new change to our model network, for example, here is our definition of our model. And what if we go ahead and we change the network, and we can say let's add one more dense layer, okay, of 10 neurons. So now we have added this. So if we change this model, if we try to retrain, what's going to happen is that your model property will change, your new model will be created, then everything will be overwritten. So if you want to store this change in a proper way, the best option will be that what you do is that you create a new experiment, because you are changing something in your network. So now what you could do is that you can come back here and you create a new experiment. So if you come back here and you launch this experiment method, and very quickly you will see that in your workspace with project, you see that a new experiment is created. And if you see this previous experiment, because remember when we were completing the previous experiment, as you could see here, because the experiment was restarted, so some of the information from related with previous experiment is already being pushed into here. So like a notebooks, Jupyter. If you will not start the second experiment, then the best option for you is to, before you close your experiment, make this call. At the very last we have experiment.end, and I didn't want it to end the experiment, I just wanted to restart a new experiment. So experiment changed and the previous experiment related information were uploaded, and then a new experiment is started. So this was our previous experiment, now which was the shift lintel. Let's come back here, and now this new experiment is available, and as you could see here, there is no data for us. Now we have experiment started. Now we don't need to do anything because our data is already available for us. We just need to change the model. So now our model is different, and let's try to visualize our model. Now you could see here. So now we have our network this way. In this layer, input is 30, output is 20, then output is input is 20, became 10, and then from 10 neurons to your final output layer, which is the last target, whether the disease is having disease for this person is true or false. So this is our new network. Let's run the experiment. So training is started, and very soon we are going to see experiment. So now they want us to reload the page, and here are the data. One good thing with experiment is this color. So depending on what experiment color is, you are going to get metrics in those colors. So you see this is a red. So this is one really very nice way I just found out is quite interesting, and it's a very useful feature. So everything is okay. Our histogram is already available. So everything is okay so far. Let's come back to our experiment. We just really need to look into our model accuracy. That's the model accuracy. We are going to save this model, and at this point we could either rename it, or I just, because it's a different model new, if I want to keep it, because I will just upload it and I will download whatever model I really want. So model is saved. Then we are going to log this model. So now we are logging this model. So we have logged this model. Now in Comet server, our model is logged. And here is our new model. And now we could register this model, and as you could see here, save to existing. So we are saying that the previous model, which was the Keras heart disease model, I have created a new model and just call it 101, and let's save it. Now we can go look into our model registry. Here is the model registry. Still there is a one model, but there are two versions now. And we can look into the models. As you could see here, that this is my very first model. I could download it and I could use it, and this is my second model. Sorry, these are the experiment, but I could download from here. And this is how we could use Comet platform to keep using experiment as we change. And if we would want, we can actually go back to notebook 2 and we can work on previous notebooks. If I go look into the previous experiment, because this has the notebooks available. So that's also the very good functionality available through Comet Monitoring Platform. So that's how you are going to not only monitor your experiment or machine learning and deep learning experiment, depending on which engine you are using, but also you could monitor whole process, as well as you can manage your models. One very good thing I wanted to just show you, that when we are in this model page, we can go look into these models. If we would want to, let's reload. So this is a 1001 model. Let's go look into the both models. Edit model. So edit model is just like a property. Second model, I could update it. Here I'm downloading model 1. Here I'm downloading model 2. So here, after we have downloaded these models, so this is what the zip look like. So this is the latest model, or maybe this one. Latest model is here, and here are the files which are uploaded from local runtime, and here is the model which is the older model version, which is 1.0.0, and it has these multiple files because we have ran experiment 2 times. So that's why the consistency between these model files has been changed. And just for the sake of completion, we can finally run this experiment.end, and while doing this experiment.end, most of these details will be saved here, and as you could see here, source code, notebooks, model, histogram, all that information is available. And depending on your experiment type, you have the ability to even push your data, or metadata related with your experiment can also be pushed. So that's upload is almost done here. So we can come back, look into. So based on this tutorial, we learned that how you could send your models or export your models from your runtime environment to Comet Model Registry, and then you can get all the information related to your model. So remember, the model registry where the models are stored, but in order to get the details about your model and other things, you really need to go back to your experiment, and you can look into. So that's all I had for you in this video tutorial. Please enjoy this content, and I hope to see you in my another video. Thank you. That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.